Alright, hello everyone. Welcome to today's lesson on adding and subtracting polynomials. Alright, so today our goal is to look at a big and long polynomial and then shrink it down into just a few terms so it's easier to read. Alright, so like I said here, people like me, mathematicians like me, are super lazy, but if we see too many of those terms, right, we want to simplify them and combine them as much as we can. And now the first step is to always look for the common terms. Right, so terms that share the same variables and the same powers. So in this case, we can see that we got 2x here, right? Plus 7x and then plus 36x. Right? Remember the signs in front of them. Right? So in the case of the 2x, because there's no signs in front of it, we just assume it's plus. Right? It's a positive number. Okay, so all of them have the same variable, x, and the same power, which is x to the power 1. Right, of course, we got x squared here. Right, so those are a different clump. Right, x squared, even though the same variable as x, it's a different power. And of course, we just have the constant, right, just the number by itself, just a plus 5. So now after that, right, we can then rearrange them. So we got the greens, right, the x by itself. And then we got the squares. And then just a constant. Again, right, so we got the little green section here, right, the blue section, and then the red. Right, so we are just rearranging that so that it can combine together. And after that, we add them up. Whenever we add polynomials up, the variable will never change. Right? Only the coefficient or the number in front of it will change. Right? So in this case, we have 2 plus 7 plus 36, right, which is 45x, or 45. Right? We just tag the variable behind it. Right, so very important here, it doesn't become 3x or like x cubed. The variable stays the same. Alright, next, we have 1 plus 3 for the x squared. Right, so remember, if it's just a variable by itself, we just assume there's a 1 in front of it. Right? Because we're lazy, don't want to write that. Oops. So it's 4 squared. And of course, the 5 just stays the same. Right? And then we're pretty much done here. The last step we usually try to do is just like a good practice is to rearrange them so that the degrees are descending and it's alphabetical. So in this case, the squared goes in the front because it's to the power of 2, x to the power of 1 is next, and then x to the power of 0 or no variable at the very back. And so descending order from highest power to lowest power. Okay, so let's do some other examples here. Okay, so you can see it doesn't really matter what variable it is. Now we got two a's here, right, and then a constant by itself. So first we rearrange. We got 12a minus 6a, and then plus a 10. Right, so the 10 is now there, and then the a is over there. Right, and of course, once again, we always work with coefficients. So in this case, 12 minus 6 is 6. The variable stays the same, which is a plus 10. 10 doesn't change. Okay, so like I say, gotta be really careful about what variables you're working with here. So first we got a BC. So whoops, that's not it. Got a plus 2BC and a minus BC. Now we got a plus 8B and a minus 10B. Okay, so alphabetically, we got BC first, and then we got just a B. And just like how you'll sort something alphabetically. Right, from there, got 14 plus 2 minus 1. Right, because it's just minus BC, doesn't have anything, so we can just assume it's minus 1 BC. 14 plus 2 minus 1 is 15 BC. Next is 8 minus 10. It's negative 2 or minus 2b. Just like that. And so both alphabetically and by degrees. Right, and of course, there's different ways we can actually go about adding. Right, and now when we add two polynomials together like this, right, the brackets just indicate two clumps. Right? Suppose adding, we don't have to worry about it too much. Right, the only thing we have to watch out for though is that right here, we are adding a minus 2x squared. Right? So remember, when we have a plus and a minus together, it's the same thing as just subtraction or just minus. So realistically, we got 3x squared minus 2x plus 2, and then minus negative or minus 2x squared minus 4. Right? And then you can kind of think of it as two ways. Right? You can do it horizontally, like what we were doing earlier. Right? So we lay everything out horizontally like this. We group the numbers together, the variables together. So we got x squared here, the x by itself, and then the constants right there. We rearrange it. So 3x squared minus 2x squared minus 2x plus 2 minus 4. Notice how I'm rearranging it based on the power, right? The square first and to the power 1, and then no power. Okay, 3 minus 2 is 1, so it's just x squared by itself. Oh, yeah, minus 2x left alone, plus 2 minus 4, which is minus 2. Okay, so once again, this is how we did it earlier. But now we can also do it vertically. Right, so once again, we have our equations. So remember, we got a minus 2x squared and a minus 4. Right, so you can line it up, right, so that the same powers are lined up vertically. Right, and then we'll just use long addition or long subtraction. I guess in this case, always long addition. Right, so we got 2 plus a negative 4, which is 2 minus 4, negative 2. Negative 2x, bring it down, because think of it, this is just 0. Nothing here. 3 minus the 2 is 1, so it's x squared. Right, so both methods will work, depending on which one is easier for you. And of course, for my visual learners, you can also use tiles. Right, so we got 3x squared tiles. That's positive, so 3 of those tiles, that's shaded in. We got 2 negative x tiles, so minus 2x, so it's 2 long tiles, that's blank. And then plus 2, so it's 2 positive 1 tiles, like that. Next, we have 2 negative, or 2 negative x squareds, so it's 2 blank square tiles. Right, and then 4 negative 1 tiles. 1, 2, 3, 4. Right, and then right here, we just cancel everything out. So we can cancel out the x squared tiles like this, because it's mix and match. We can cancel out 2 of those. Right, and now what we are left with is we are left with 1 of the big x squared tiles, that's positive. Still left with the 2 negative x tiles, and then we're also left with 2 of the negative 1 tiles. So this translates to a positive x squared, 2 negative x's, and 2 negative 1's. Just like that. Right? So, of course, just like everything we talked about, use whichever method that you like the most. That's adding. Now with subtracting, we're adding just one extra step. Right? We'll actually learn more why we do this step next lesson. Right, but for now, all we need to know is that we have to flip the signs. Right, or more importantly, when we subtract a polynomial in a bracket, right, we always flip the signs. So, in our first example right here, right, 2x plus 5 remains the same. And then from there, right, we have a positive 3 plus and a minus 4. And now to flip the signs, we flip the plus 3x to minus 3x, flip the minus 4 to plus 4. Right, and that's it. That's the only stuff we gotta do. And then business as usual, we got the x's here, and then the constants here. 2 minus 3 is negative 1, so negative x. 5 plus 4 is 9. Right, that's it. We are just taking away the bracket and then subtracting it. Or not subtracting it, taking away the bracket and flipping the signs. So once again, horizontal, vertical. Right, so with the horizontal, once again, the first bracket stays the same. Second bracket, right, we got negative or minus x squared. And we also have a minus sign in front of this bracket. So we flip all the signs. Minus x squared becomes plus x squared. Plus 2x becomes minus 2x. Minus 1 becomes plus 1. Just like that. Okay. Again, business as usual. We clump all the like terms together. The one with the same variables and powers. 2 plus 1 is 3. Minus 4 minus 2 minus 6. It's negative 4 minus 2. Negative 3 plus 1, or minus 3 plus 1 minus 2. Okay, horizontal, that's method 1. With vertical, okay, same thing, we copy it down. Alright, so again, even with vertical, you still have to remember to flip the signs. Okay, minus 3 plus 1 is minus 2. Minus 4 minus 2 is minus 6. 2 plus 1, 3. Right, that's vertical. Right, so once again, you can think of vertical as just going straight down, right? We group all the like terms together. So here's the red. Group the greens here. Oh, what the? Group the greens here. Group the blue. Of course, the tiles. Two positive x squared tiles here. 4 negative x tiles here. 3 negative 1 tiles here. All right. We are subtracting a negative x squared, 2 positive x's, and a negative. Right? So once again, we have to flip the signs. It's gonna copy this. So I don't feel like where's copy? Copy, paste, voila. We flip the signs, so we pretty much just flip the shading. This becomes plus, the negative gets flipped to a positive, the positive flipped to a negative, this negative flipped to a positive. Right, once again, we cancel out anything we can. Right, and in this case, actually, only one of the ones can cancel out. Right, because both of those are already positive here for the x squared. The x is already negative. Right, so now we are left with 3 x squared tiles, 6 negative x tiles, and then 2 negative 1 tiles. So all together, oh, I don't have space for this one. I'll just write it on top. Little cursed. Don't do this. Voila. Just like that. Okay, so that's how I do with algebra tiles. Again, exact same idea. Right, so now let's try a word problem now. Right, we have a parameter of a triangle that's 12x squared plus 6x. Right, so if you remember, parameter is pretty much us adding all the edges up together. So we have our first edge. Again, we'll try to put it in brackets just to indicate they're in the same clump. We got our first edge here. We got our second edge here. Okay, and then add it to the question mark. Okay. From there, we'll have to find this missing side length. Right, so now in order to find this missing side length, what do? Right, we know the total parameter is this, and plus something else. And now, again, we'll cover a bit more about this in a next unit here. Right, but for now, we can just rearrange this equation. Right, if this whole parameter is a result of those three things added together, then just to find this question mark, we can then subtract those two sides from the total side. Right? Because if we add up all those three side lengths here, right, we get 12x squared plus 6x. So to find just this missing side here, right, all we have to do is to subtract them. So that's our total length here. We can just subtract this edge right here and subtract this edge from here. Right, just like that. Realize I did not give a lot of space here. Right, and voila, just like that. And from there, it's business as usual, right? We flip all the signs first. So we got minus 5x squared plus 3x, and then minus 3x squared minus 7x. Come out like terms. So we got an x squared, x squared, x squared, x, x, x. 12 minus 5 minus 3 is 4. Oops. Is 4. 6 plus 3 minus 7 is 2. And that's our final answer. X squared plus 2x. Okay, and here's another concept we'll learn next lesson. Again, right, there's a bunch of things we'll learn later on, but I just want to show it off now, right? Kind of get you an idea of how things gonna what this unit is about. The circumference of all the circles added up together. Right, so if you remember, circumference is 2 times pi times the radius, which is r. So in the first circle, the radius is given to us as 4. Right, the radius is the distance from the center point to an edge of the circle. Radius here is 3, of course, and the radius here. Right, what about the radius here? We know that we are given the diameter, so the diameter is from one edge to the other edge of the circle. The radius is just half of the diameter, right? We only want from here to here, not the whole thing. So we can just divide it by 2. 2 divided by 2 is just 1. Which means that the circumference of the first circle is 2 pi times radius, which is 4. Next circle, 2 pi times the radius of 3. And the next circle, 2 pi times the radius of 1. Right? As a reminder, the dot just means to multiply. Again, if you see a sign, a operation that you don't really know, chances are it just means to multiply, right? Multiply, we got x to multiply, a dot to multiply, which is literally 2 brackets, or like 4 and then a bracket 2x, right? If you don't see operation, it's multiply. And now we only worked with adding polynomials, right? But as you can imagine, multiply is around the same way, right? In this case, the pi is our variable. Right? Even though we know pi is 3.14, blah, 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 right? But in this case, we can just keep it as a variable. Right? And again, we could just calculate our calculator if we want. Right? But for now, we can treat it as a variable. And look at the coefficients here. Right? We've got a 2 as a coefficient for all of them. And we also notice here that our first part is 2 pi times 4. And just like with adding, right, whenever we are doing stuff to polynomials, we only care about the coefficients. Right. Well, in this case, more specifically, we're multiplying 4 to the 2 pi. We're multiplying a constant number to the 2 pi. So, of course, a constant number only applies to a constant number. So, 2 times the 4 is 8. So it's 8 pi. Again, notice how the pi doesn't change. All right, we're not doing anything to the pi here. We're just doing something to the coefficient because we're multiplying it by another constant. Okay. Next, we got 2 times the 3, which is 6. Again, pi does not change. 2 times the 1, 2. Okay. And once again, we're going to combine the like terms. 2, 6, 8. Add it up, 16 pi. Of course, our unit is centimeters. Right, just like that. Right? But the main gist of this lesson here is to understand. Oh, why did I just paste this? To understand the combining like terms. All right, the terms can only be combined together if they are the same variable and the same power. And again, you can do it horizontally or vertically. The one thing to note is that when you are combining terms, if we have a subtraction sign like this with the brackets, right, then that means we have to flip all the signs inside. Right, so very tricky here. Always flip the signs inside. Again, we'll explain more why we actually flip the signs next lesson. But with that being said, good luck practicing.